Stanford Math Tournament 2013 Advanced Topics Tiebreaker number 1. Andrew flips a fair coin 5 times and counts the number of heads that appear. Beth flips a fair coin 6 times and also counts the number of heads that appear. Compute the probability Andrew counts at least as many heads as Beth. So let's imagine that we're Beth for a minute and we're on her last flip, her 6th flip. There are 3 possibilities that we have right now before she flips. The first probability is Andrew has more heads right now. I'll just abbreviate A for Andrew. Andrew has more heads. The second probability is that Beth has more heads. The third probability is that they both have the same number of heads. Okay, so what's the probability that they both have the same number of heads? Let's just call that P. Well, if that's P, then what's 1 and 2? What's the probability of getting 1 or 2? Well, the probability that A has more heads, that's going to be 1 minus the probability that they get the same amount, divided by 2. Similarly for here, right? Because you're cutting out the middle, and then you take out the side, the cases in which Andrew has more heads, and you do that similarly for Beth, so they should be symmetric. Okay, so we have these probabilities. So what happens when we flip her coin, her 6th coin, in case 1, where Andrew has more heads? Well, if Andrew has more heads, then no matter what Beth does, if she gets tails or if she gets heads, Andrew's going to have at least as many heads as Beth. So this case is great. No matter what happens, we get a successful outcome. But what about the second case, where Beth has more heads? Well, if Beth already has more heads than Andrew, then regardless of what the coin is, whether it's heads or tails, won't affect the outcome. The outcome will always be that Beth has more heads, and Andrew can't do anything about it. So this is a failing case. Now let's look at the third case, where Andrew and Beth both have the same number. Well, depending on whether Beth gets heads or tails, Andrew could win. See, if Beth gets a tail, then they're both going to have the same number, and that's valid. If Beth gets a head, then Beth is going to have more heads total, and that's a bad scenario. Since this coin is fair, there's a 1/2 probability of each chance. So we're going to have a 1/2 P probability of Andrew getting at least as many heads as Beth. Okay, so this case is successful, this subcase is successful, and this case is also successful. So why don't we add these two up? When we add these two up, 1 minus P over 2 plus 1/2 P. Well, we have a variable that's kind of annoying, but maybe they cancel out. Let's see what happens. Well, if we get everything under one denominator, or one fraction, sorry, we see that 1p, and negative 1p both cancel out. And then you just get left with 1/2. So the probability is surprisingly 1/2.